Hi everyone, I'm sorry that I'm not in class with you today. However, just like we did the other day, I'm going to ask that you complete the do now question that you see in front of you for today's notes, which is listed under today's date, 10/27, and it says 4-2, okay, notes, which is under trinomial factoring, and it might be abbreviated DOTS, which is difference of two squares. So that's what we're going to do. So please work on this do now. All right, and also check your homework, which I posted the answer key for. Okay, so you have two things to do for me, and you can pause the video and take care of the do now and checking your homework, and then come back to this video. Okay, so what we see here are some mini puzzles based off of knowing products and sums. Now, we did word problems. Okay, so we do know product means to multiply, and we did realize that sum means to add. So if we try to think of all things that can multiply together to create a -8, all right, the items that can multiply together become -8 would be 1 and -8, 2 and -4, but also if the 1 was negative and the 8 was positive, or if the 2 was negative and the 4 was positive. Okay, so we have 4 different options here. Out of all of these options, we also want to know which one will sum or add to the value -2. Now, 1 and 8 are 7 apart, so it's definitely not going to be them. All right, 4 and 2 are 2 apart, and they're different signs. So that's definitely going to be one of those, and we would want to keep the one with the larger number being the negative value. So 4 being the negative would give us 2 plus -4 as -2, but 2 times -4 as -8. So the numbers in question here were 2 and -4. Now, if you put -4 and 2, that doesn't matter. And we're going to see that sort of ordering difference will not matter in today's lesson either when we move on to see why I had you do these questions. Okay, product of the numbers is 6. So two numbers can multiply to 6. That would be either 1 and 6 or 2 and 3. But let's not forget that two positives will multiply to a positive, but also two negatives will multiply together to be a positive. So we could also have two negative values of 1 and 6 or 2 and 3 each. If I try to see, we are trying to add or have a sum of -5. So since our sum is supposed to be negative, two positives won't cut it this time. We definitely know it's not going to be them. So it's going to be one of these two. All right, -1 plus -6 makes -7, whereas -2 plus -3 makes -5. So -2 and 3, both negative, would be our answer. And again, if you put -3 and -2, that's okay. All right, for our next one, -24. So again, a positive and a negative have to be used. Now let's start getting smart with this. Instead of having all of these options and considering both, we want them to add to 5. We want them to add to a positive number. So last time when we had a negative product, I had said, okay, let's make the first numbers positive and the second one's negative, and then reverse it. The first one's negative and the second one's positive. Well, we can be a little smarter down here because if we know they're going to add to be a positive number, we want the bigger number to be the positive. So I'm always going to make the bigger number positive when I break down the number 24 into numbers that could multiply to it. So -1 and 24, if you multiply them, they would become -24. -2 and 12 would work. -3 and 8, as well as -4 and 6. So these are the 4 possibilities that I'm going to focus on. I'm not going to worry about switching these to positives and these to negatives, because if I did that, they'd be adding to negative numbers, and I want a positive. So I'm going to look which one of these groupings adds to +5, and that would be the -3 and the 8. So -3 times 8 is -24. -3 plus 8 is +5. Those are my numbers this time around. Okay, and then number 4, down here, okay, I have 2 numbers multiplying to 44. That could be 2 negative numbers or 2 positive numbers. When I see that I'm asked for those numbers to add to be a negative, well, I'm going to use negative numbers then. So what we're going to do is use negative 1 times negative 44, negative 2 times negative 22, negative 4 times 11. Those are possible, negative 11. Those are possible numbers that will multiply together to be positive 44. The ones that will add together to be negative 15 will be negative 4 plus negative 11. So those two numbers together will end up being what multiply to 44 but add to negative 15. Now the reason I'm having you focus on that is for a special type of factoring that we can learn about. That factoring would be called trinomial factoring, and that's when we want to take a trinomial and break it down into two binomials that could have multiplied together to create it. So what I see down here is something in the form x squared plus or minus bx plus or minus c. Okay, now just so you know, b is the value that we want our numbers to add to. And c is going to be the number we want our values to multiply to. And you're going to see what I mean in a second when I reverse the process for something that we're going to do. So if we have something in this form like x squared plus 5x minus 6, okay, so the b and c are replaced by a number, we're going to be able to break it down into two binomials. You know, there's not everything filled in here, but this is going to become two binomials. Okay, and then we have to pick signs for our binomials. And that's what I was focusing on in our do now, of when we were paying attention to the signs of what we were adding or subtracting to. So there's a little memory trick down here for you if you want to take a look at it. So if the numbers we're adding to were positive and the number we were multiplying to are positive, well, it's going to be a positive times a positive. If the numbers you're adding to are negative, but you're multiplying to become a positive, that's going to be two negatives. Okay, so you'll notice if the c value has a plus sign next to it, we're going to use two of the same sign. The sign matches what was in front of our middle term. However, if we end in a minus c, or we're a negative number, we're going to have to use one of each. And this is what I was saying before, that the order doesn't matter. They could be put either way. All right, and then we're going to select the numbers that we should have had. So in order to break these trinomial examples down here into pairings of two binomials that would multiply to become them, we can use the sum and product rules to our advantage. Okay, so if I look at the numbers that are used in this question, this is trying to tell me I want to multiply to a value of 6, and I want to add to a value of 5. Once I can determine what two numbers multiply to 6 but add to 5, I'll be able to take the trinomial and turn it into two binomials being multiplied together. So in this case, the number 6 could be broken down into 1 and 6, or 2 and 3. They would be both multiplying to 6, but they add together to become 5 if I choose the 2 and the 3. So what I can do is take the trinomial, turn it into two binomials being multiplied together. One of them is going to be an x plus a 2, since I picked positive 2. And the other will be an x plus a 3, since I chose a positive 3. So these values I choose go into the ending of each binomial. And what you'll notice is if we tried to reverse the process and actually multiply these two binomials together, they would become x squared plus 5x plus 6. Because x times x, our first terms, become x squared. Our outer terms, x times 3, become 3x, but our inner terms become 2 times x, which is 2x. Now 3x and 2x, they're like terms. They would put together to make 5x. And then our last terms in that FOIL method, 2 times 3, would become 6. So these, via the FOIL method, or for those of you that like the grid method, you could use that as well, they would multiply together to become this trinomial. So we're learning how to go backwards from that process that we learned in unit number 3. All right, let's try this again for a new problem. Okay, and this actually uses numbers from up top. Okay, in our do now. We already did this question. What adds to negative 15, but what multiplies to positive 44? So if we look back up, that was the last do now problem I gave you. The numbers that added to negative 15, but that multiplied to 44 were negative 4 and 11. So that means this trinomial can turn into two binomials, one being x minus 4 and the other one being x minus 11. All right. Next one. What adds to positive 5 and what multiplies to negative 24? Well, we did that one in the do now as well. The numbers that added to 5 but that multiplied to negative 24 were negative 3 and 8. And just to emphasize that order doesn't matter, that means if you use the negative 3 and the positive 8, you could write your binomials in this order if you'd like, or an acceptable answer would be doing the positive 8 first and the negative 3 second. It doesn't matter, because in either of these situations, x times x will happen to get x squared. A negative 3 times an x will occur, and an x times a positive 8 will occur, giving us a positive 8x and a negative 3x, which combine to make a 5x. And both of them also finish up with negative 3 times 8, or 8 times negative 3, which are both negative 24. So that's working to our advantage. All right, and let's look at this last one. All right, here we have what multiplies to negative 8 and what adds to negative 2. So if I want to decide that, I would break negative 8 into two pieces. We are trying to get them to add to be a negative, so I want the bigger number to be a negative. So 1 times negative 8 could be negative 8. 2 times negative 4 could be a negative 8. Which one of these add to negative 2? Well, that was the 2 and the negative 4. So x plus 2 times x minus 4 would be two binomials that would multiply together to be this trinomial. And again, that was just coincidentally one of our do nows. So we've already learned how to do that split. All right, what I'm going to do is do some of the examples on the next page with you. So we'll do these 8 questions. I'll show you that process again. And then I'll show you another type of factoring method that we can do. Okay, so we're going to do these 8 problems, learn a new one, and then do 8 more questions. There's going to be so much more practice for those of you that feel like you want to do more of these to get them down. I'm not going to show them to you in the video, but they will be posted. So after the video, if you want to take a look at those, I'll show you what those sheets are. You'll be able to do that. All right, so let's factor each trinomial here. So we need to figure out what multiplies to positive 12. So I'm going to take the 12 and I'm going to break it down into two pieces. If I look at what I'm trying to add to, it's a positive 7. So I'm going to break the 12 down into factors that end up being positive only. That's all I'll have to worry about. So I have 1 and 12, I have 2 and 6, and I have 3 and 4. Those are the different ways I can multiply to 12. However, positive 3 and positive 4 are the ones that will add to positive 7. So the answer to this question would be x plus 3 times x plus 4. That's my final answer. If I try to decide what multiplies to 2 but adds to 3, well, the number 2 can only be broken down one way, into 1 times 2. And those numbers happen to also add to that positive 3 I'm looking for. So x plus 1 times x plus 2 would give me what I was looking for, two binomials that multiply together to become that trinomial we started with. What multiplies to 10 but adds to negative 11? Well, now I want negative addition to happen. So that means 10 I'm going to break down into negative values. Negative 1 times negative 10 would be positive 10. Negative 2 times negative 5 would be positive 10. And those are my only options now. However, it's negative 1 and negative 10 that add to negative 11. So x minus 1 and x minus 10 would be my two factors, my two binomials. All right, last one on this line. We have 48 as what we're trying to multiply to. It's a positive, so that can either be a positive times a positive or a negative times a negative. I'm going to do negatives times negatives because I want this sum to be negative 14. So negative 1 and negative 48 would make 48 if I multiply them. Negative 2 and negative 24 would. Negative 3 and negative 16 would do that as well. Negative 4 and negative 12 would. I ran out of room, so I'm just going to move up here and keep doing some splits. Okay, negative 6 times negative 8, and now I'm finally out of all of my options. So if you notice, I tried dividing 1 in, then I tried dividing 2 in, then 3, then 4. When I try 5, it doesn't work. I tried dividing 6 in, and it worked. So that's how I'm creating these lists. I'm not just getting them off the top of my head. I'm trying to think of my times tables to get to 48. Out of the 5 options I just created, it's the negative 6 and the negative 8, which would add to negative 14. So x minus 6 times x minus 8 is my answer, those two binomials. Okay, 18 can split into negative 1 times negative 18, negative 2 times negative 9, and negative 3 times negative 6. Out of those options, negative 2 and negative 9 would add to negative 11. So x minus 2 times x minus 9 would be my answer for that one. What multiplies to negative 6 but adds to, well, there's nothing there. So let me put my coefficient of 1 as a placeholder. So what adds to negative 1 is what I'm looking for. So I'll try 1 times negative 6, and I'll try 2 times negative 3. Because a positive times a negative will be a negative, but when I add one of each, I'm going to keep the sign of the larger value. So 2 plus negative 3 would get us negative 1. X plus 2 times x minus 3 is my answer. All right, what multiplies to negative 6 but adds to negative 5? Same situation as before. We're going to have the same exact options, but instead of choosing 2 and negative 3, I'm going to choose 1 and negative 6 because those add to negative 5 this time. So we had the same choices between these two, but because the middle value is different, we're going to have to change that. And I just realized, I'm not going to redo this video, okay? I just realized I've been making a mistake this whole time with all of you. So I'm going to have to go back and correct that. I've just been so used to using x's that I wasn't even paying attention that at number 4, our variable letters had changed, okay? So these used y's, and then I said x down here. So I apologize for that. Those should have been y's. And in question 5, they used the variable a. I just got on a roll using x's, so I'll use an a for those two. Okay, and then the m should have been used for question 6. Then it went back to x for question 7. So sorry about that. You have to use the variable that's in the problem. Okay, bad for me to do that. All right, and then we have negative 8. Negative 8 can be broken down into 1 and negative 8 being multiplied, 2 and negative 4 being multiplied. But the ones that add together to make negative 2 are 2 and negative 4. So y plus 2 times y minus 4 would be our answer. Okay, so if you want to take a trinomial and see if it can be written as a multiplication problem of two smaller termed items, two binomials instead, figure out what numbers multiply to the number on the end and add to the number in the middle attached to the x. That's called trinomial factoring. Okay, but you can see there's a question down here for you. What if there's no b value? B value referring to the fact that when I wrote this out for you before, I referred to the number in the middle we were adding to as b. So you can see that's gone. There's nothing with a plain old x to the first power in this example here. Well, that has a different type of factoring that we can use called DOTS. That's an abbreviation that stands for difference of two squares. Difference referring to the fact that we can only do these questions if the two terms, the x squared and the 9 in this case, are being subtracted. That's the difference part. The two squares part refers to the fact that either number on the sides of the subtraction sign are what are called perfect squares. They came from two of the same item multiplying together. In this case, x times x, and in this case, 3 times 3. Okay, so that's what our instructions down here say. Factoring with dots, something that's in this weird form a squared minus b squared, or most people end up saying a squared minus c squared. Okay, that's also going to work for it. Something in this form, you can follow these steps. Have to have a subtraction symbol. That's step 1. You have to make sure things to the left and the right are two terms are perfect squares. So here's some examples of perfect square numbers. They keep going on, but this is up to 10 times 10. And here's some examples of how variables would look like. So x times x could be x squared. X squared times x squared could be x to the 4th. X to the 3rd times x to the 3rd would give you x to the 6th. So anything that has an even exponent would also count as a perfect square. Okay, and we're going to basically break it down into two binomials again, but it's going to be pretty specific as what happens. You can see in both of these cases, it doesn't matter which order they are in, we're going to put one as a plus and one as a minus, and I'll show you why that happens. So if we're trying to think to ourselves for x squared minus 4, well, it is subtraction, but what multiplied to get x squared? Well, that would have been an x times an x. And what would have multiplied together to create a 4? Well, that would have been a 2 times a 2, two of the same number. But here's the catch. Remember, whatever sign's written in front of a number goes with it. So this, even though I was talking about this as a subtraction, we were really trying to view this more as a minus 4 or a negative 4. So even though 2 times 2 is 4, one has to stay positive, the other would have to be negative. And so this reveals to us that we can rewrite this as an x plus a 2 times an x minus a 2. So x plus 2 times x minus 2 would result in another type of binomial. Two binomials multiplied together would make this binomial x squared minus 4 called a DOTS problem. Now here's why that happens. Okay, now normally for these questions, this would be your final answer, and you'd stop there. But just to show you where this comes from, if I FOILed this out, I'd have x times x, then I'd have x times negative 2, I'd have 2 times positive x, and I'd have 2 times negative 2. When I try to put these 4 multiplications together, I have the x squared, I have a negative 2x, I have a positive 2x, and I have a negative 4. So I would write this as x squared minus 2x plus 2x minus 4. And those make 0x. They're gone. It would just become x squared minus 4, what I started with. So anytime you see a difference, a subtraction problem, a difference of two perfect squares, a difference of two squares, you can figure out that it's going to multiply to two binomials right away. Okay, factor to two binomials, one with a plus, one with a minus, and one with each of the items that would have multiplied to create the numbers on either side. So 64 is 8 times 8. X squared is x times x. So 64 minus x squared would be 8 plus x times 8 minus x. And we're done with it already. What multiplies by itself to get 16m squared? Well, 16 is created from 4 times 4, and an m squared is created from m times m. So that must have been 4m times 4m. And 1 is 1 times 1. So that's another perfect square. So this is a difference of two squares. And we could factor this by having 4m plus 1 times 4m minus 1. You can see they look identical every single time except for one little minor detail. one's being added, and one's being subtracted. Okay, that idea is called conjugate pairs. So if you hear me say the phrase conjugate pairs, I'm talking about two binomials that multiplied together, okay, but they looked identical except for their operation in the middle. All right, what times itself is y to the fourth power? Y squared times y squared is y to the fourth. And what times itself is 100? That's 10 times 10. And it was a difference problem. It was a subtraction. So y squared minus 10 and y squared plus 10, one of each operation in each of those binomials would be the correct way to factor it. All right, so why don't you pause super quick, okay? Try the next four on your own and come back and check your answers with me. All right, so for this one, we should have had 4 minus n times 4 plus n. And that's because 4 times 4 is 16, and n times n is n squared. For our next one, we should have had 5x minus y and 5x plus y being multiplied together. Either order is fine, so these parentheses could be switched around. Okay, and then that's because 5x times 5x is 25x squared. Y times y is y squared. All right, the next one should have been 1 plus 10xy, and the other one 1 minus 10xy. Because 1 times 1 is 1, and then 10xy times 10xy would be 100x squared y squared, from when we learned how to multiply with binomials or even monomials for that case. And then here our last one, we should have had y squared plus 2 and y squared minus 2, because y squared times y squared is y to the fourth, and 2 times 2 is 4. So that would be our final answer. Okay, so if you feel like you are going to need more practice with these, I have several sheets still attached to this. Okay, one that I want to point out to you looks like this. It says finding factors, sums, and differences. So if you just feel like for the trinomial method that we learned first today, that you need more practice of figuring out what two numbers multiply to something and then add to something else, this sheet will get you great practice for figuring out different numbers that multiply to a certain number but add to a different number. So this one will be great for that. Okay. Other than that, I also have plenty of extra practice problems for trinomial method factoring, which we have here. Okay, or we also have D.O.T.S questions on this sheet for you to try. Okay, those are all completely optional, your choice if you feel like you need to look at those. If you're feeling pretty good, then the homework should have already posted by the time you're done watching this video. So you can go ahead and move on to the homework, which contains trinomial factoring from the first one and binomial factoring that we did second right here. Okay. So I will see you all tomorrow. If you have any questions, please let me know when I see you in class. Thank you so much.